All right, this is lesson 4.4, dilations. Remember, we've been talking about similar figures and we've been talking about scale factors and that type of thing. So today we're going to continue with that same thought process. And we're going to talk about what happens when you take two shapes and you make that they are already similar and you make them shrink or enlarge. Okay? So the definition of dilation is the reduction or enlargement of a figure. Can anyone think of a real life example where you deal with a dilation of something? Julia?
You're having a baby.
Oh, you went there. When you're having a baby, we'll stop it there. Where else can you think of a dilation?
Maybe like prop toy cars or something like that. Maybe.
Okay, toy cars, model cars, right? They're an example of that. Good. Natasha?
When you make bread.
When you make bread?
Yeah, when bread rises.
Oh, it enlarges. Okay. What else?
Your pupil.
There, that's what I was looking for. Your eyes, your pupils, right? Like when you go to the eye doctor, they dilate your eyes and they tell you, please don't drive because your pupils are huge, right? So a dilation, we're going to either reduce or enlarge a figure, okay? The scale factor, and we've heard that word before, the scale factor indicates how much the figure will enlarge or reduce. Okay, so that's how we're going to tell whether it's an enlargement or a reduction, not just looking at the picture. The variable for this scale factor is K. So they're going to use K to say, hey, this is your scale factor. When K is greater than 1, the dilation is going to be what? Do you think it's going to be an enlargement or a reduction? Okay, it is an enlargement. My English people, what gave that away there? If that was a blank.
Okay. Greater than.
No. Well, I mean, that's the math. A and an, right? An is preceded. You precede a word with an if it's a vowel, right? An enlargement. These are called context clues, my folks. Or when K is less than 1, the dilation is a reduction. Okay, so if we are looking at this picture over here, we have triangle ABC, and then do you see the little triangle has like apostrophes next to it? You guys see that? We call that A prime. They use the word A prime, B prime, C prime. That's what the little apostrophes mean. All that means is that the big A is the original, and A prime is after you have already done a dilation to it. So it's the new image. Okay, so the prime, the little apostrophe things, mean this is called the image after the dilation, and the original is called the pre-image. So the original is called the pre-image. After you perform the dilation, it's called just the image. Okay? So let's look at this example. It says triangle RST with vertices that is going to be dilated, and we are supposed to graph and label the figure and then graph the image. All right, so the first thing that I want us to do is I want us to plot the pre-image. Okay, so plot the pre-image, and sometimes when you make that triangle, sometimes it's a dotted thing, but because these graphs are kind of hard to see, if you want to use a highlighter to help, you are welcome to do that so that you can see the pre-image versus the image. So RST, does anyone want a highlighter or a color pencil or anything? Okay. So I'm going, and make sure you label R, S, and T. Again, these little graphs are pretty hard. R is at -5, 1. S is at negative 3. 4. And T is at 2. So we typically use a dashed line to represent the pre-image. Okay, so there's your pre-image. And if I want to dilate this by 2, do you see where it says K equals 2? All that means I'm doing is multiplying every X and every Y by 2. So before you graph it, I want you to write down the new coordinates. So negative 5, 1, if I dilate that by 2, first of all, is this an enlargement or a reduction? Enlargement, so let's write that. It's going to be an enlargement because K equals 2 and 2 is greater than 1. So if I take R is negative 5, 1, and I multiply each of those by 2, I get negative 10, 2. So that's the new coordinate of R is negative 10, 2. Everyone see where that came from? No? So I took it says to enlarge it by 2. So I'm going to take each one of these and multiply by 2. So negative 5 times 2 gives me negative 10. And then 1 times 2 gives me 2. Okay, so then negative 3, 4 is going to turn into what, Ashley? What is negative 3, 4 going to turn into? Negative 6, 8. So I took the original S values and I multiplied each of them by 2. Okay, what about T, Monique? What's going to be the T prime value?
That'd be 4 and 2, right?
4, and then what kind of 2? Negative 2. Good. Okay, so now with a different color, hopefully you have 2 different colors of pens or markers or something. Again, you're welcome to go grab some. Let's go ahead and graph our image now. So negative 10, 2. You can sharpen them if you want to. And I'm putting an R prime. So when I label that point, I have my R and then the apostrophe. Okay, because that's my new R prime.
My friend was doing not right.
What happened?
Five and 1, right?
5 and negative, or it's negative 5, 1. Okay.
Right.
Where's negative? Negative 3, 4.
4.
And then 2, negative 1. Nope. 2 on your X. 2, negative 1. There you go. You might want to label them. And then 4, negative 2. So then your triangle should look bigger. Yeah? Everyone okay with that? The image, the new image should be a solid line. Okay, so your pre-image is dotted. Your pre-image is dotted. And your image is solid. If you need to make a note of that at the top, do that. Yes. Always. Yep, the pre-image is always dotted. It's like the memory of where did it used to be. And then your image is solid. Okay? Okay, why don't you try number 2? I think you can try number 2. Before the very first step is to plot the original. Okay, so you're going to first plot the original. Make sure you label the points. And this time our scale factor is 3. So is this going to be a dilation? I'm sorry, is this going to be an enlargement or a reduction, Carla? Good, an enlargement because the K value is greater than 1. Okay, so now you're going to go ahead and find your points. Remember, you're multiplying every x and every y by 3.
Okay. I know I left them on pause. How do I do these numbers?
These right here? And first of all, you need to label this. R, S, or A, B, C, D.
Does it matter?
Well, it does matter which ones are which. Nope. This is C, and this is D. Okay, let's try number 4. Go ahead and plot your triangle. I said, yeah, we're going to skip 3 because I think you're getting the hang of it. Number 4 is a trickier scale factor than number 3, so.
Okay.
This is quite a large triangle. Okay, Hortensia, is this an enlargement or a reduction? It's a reduction, right? Because you guys see your K value is less than 1. So we're not going to multiply by 2, Brian. We're going to multiply by 1/4. Multiplying by 1/4 is the same as doing what? Dividing by 4, right? Multiplying by 1/4 is the same as dividing by 4. So we're going to divide each of these by 4. And it's okay, like on X, 10 divided by 4 does not go evenly. And so you can leave it as a decimal. Okay, and you're going to plot the best that you can to estimate there. Go ahead and find the new coordinates for W prime, X prime, and Y prime. Multiplying by 1/4 is the same as dividing by 4. Remember, your shape of your of your image should look the same after you've graphed it. Okay, so go ahead and graph your image, which is the new one. Go ahead and graph your image, which is going to be the new one. All your letters should look like they're in the same location, just shrunken. And again, when you are labeling these points, make sure you're putting W prime, X prime, Y prime. Okay. Okay, any questions on number 4? You have 3 other people at your table, Julia. Well, they can help you out.
I accidentally did it this way, but I redid it.
Which one is this? So just scribble this. Actually, let me get you a whiteout. Okay, any questions on that? How do you feel? How do we feel about this? Okay? Hard? Okay, let's look at our homework because I want to show you a problem on your homework, okay? That's a little bit tricky. So if you look, there's no way what? Let's look at like 3 and 4. You see where it says you're going to multiply the scale factor on number 3 by 4/5. Okay, is that a reduction or is that an enlargement? It's a reduction because 4/5 is less than 1. So guys, you're going to have to do a little bit of fraction work, and you have space around the edges that you can do it. But to do like 5 times 4/5, let's do this one together. So if I want to find P prime, I'm going to take this 5 times 4/5. Well, that means that 5 is really over what? 1. 5 times 4 is 20. 20 divided by 5 is 4. Does everyone see where that came from? So I did 5, which was the x-coordinate of the P, times 4/5. And 5 is over 1, so multiply straight across your fraction, straight across. 20 over 5. Then if you want to do 15 over 1 times 4 over 5. So we'll do this one now. 15 times 4 is 60. 60 divided by 5 is 12. Okay, so you're going to have to multiply fractions, and that's okay because you all have passed algebra, and this is how you work them. All right, you multiply the top, divide by the bottom. Lexi, what are you doing? Okay, and then are you getting a decimal, or you're getting whole numbers? Yeah. Okay, so 0.8 would work as well, but if the problem comes out that's not going to be, like if it was coming out as a decimal, it might be helpful to have it as a fraction. Okay? But you're right, 4/5 is 0.8, so it would be the same thing. Okay, so your homework today is to do 1 through 6. That's it. 1 through 6. And then we're ready for our study guide. So if you get done with 1 through 6, short lesson today. Only one lesson. When does that ever happen? Okay, only one lesson today. 1 through 6 is your assignment, and then you can work on your study guide. I do not have the answer key for the study guide yet. I will work on that as you guys are working so that you can have that before you leave today, okay? Yes, Natasha?